Go ahead and read this question about momentum and see if you can pick out some key words. Did the question ask about momentum or did it ask about change in momentum? That makes a big difference actually. Did the question give you the mass of the car or the weight of the car? That also makes a big difference. So when we're talking about momentum, as soon as you see momentum in the question, you're going to say, what do I know about momentum? So I'm going to write right here, what do I know about momentum? You don't necessarily have to write that whole thing out every time, but you are going to list the things that you know about momentum. And for one thing, I know that we represent it with the letter P. Remember, we ran out of letters in the alphabet. M already stood for mass. So P is momentum, and momentum equals mass times velocity. Just a side note, mass is a scalar because direction doesn't matter, and velocity is a vector because direction does matter, which means momentum is a vector. So the direction of someone's momentum makes a big difference. Okay, anything else we know about momentum could be put right here. Did you decide if this was the mass or the weight of the car? Remember, we can say mass versus weight. We can put here if you're trying to figure it out, and you would say something like, well, I remember that weight is a force. Weight is force of gravity. So force of gravity, and we know that force equals mass times acceleration, so that must be the acceleration of gravity. If weight is a force, we already know our answer. That's not in newtons, so that must be a mass. If we wanted the force, we could put 9.8 as the acceleration of gravity, meters per second squared, and we can put the mass here and find the weight. But we don't need it because in momentum, we want mass. All right, now we want change in momentum. And for change, I want to remind you what change means. Change means the second or the latest or the last or the final minus the first. Change equals last minus first. And think about this. If you went from 8 meters per second to 0 meters per second, and you said, what is your change? We went down 8 meters per second. You wouldn't say that your change is 8 minus 0. You would say that your change is -8, which is only represented by 0, the last, minus 8, the first. That double checks that I did this in the right order. Okay, so back to momentum. If we want the change in momentum, we must want, now is the mass changing, or is the velocity changing, or are both of them changing? Hopefully you can see that the mass of the car is staying the same, the velocity is changing, so the mass is going to stay the same, and the change in velocity is going to be the latest, the final, minus the earliest or the initial. And then we're going to go ahead and put in a calculator. And what I'm going to do is I'm going to say delta P equals 625 times 34, make it easy on myself. And then I'm going to get a calculator, maybe. I'm going to do 625 times 34. And I get 2,100, blah, 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 blah. Change in momentum equals 21,250. And the units, remember that we're looking back up at momentum. Momentum is mass times velocity. Mass, the units are kilograms. Velocity, the units are meters per second. So the units are going to be kilograms, meters per second. Done.